Here's the question this whole idea turns on, and the honest answer up front, before the science fiction gets to it. Superintelligence means a machine that's smarter than every human, across the board. Smarter than you, smarter than any expert, smarter than all of us put together. Not a faster chatbot. A mind that stands to us roughly the way we stand to a chimpanzee. And the honest answer to what happens after we build one is this: nobody knows, and that's exactly why serious people are nervous. Every other tool we've ever made, we could outthink when it went wrong. This is the one defined by outthinking us. The strange part is how old the idea is. A codebreaker who worked alongside Alan Turing wrote it down in 1965, and the argument he made has barely changed since. Start with the latter, because the word gets thrown around loosely. Today's AI is narrow. It's superhuman at exactly one thing, chess, or protein folding, or predicting the next word, and lost the moment you take it outside that lane. The next rung up is what the last episode called AGI, Artificial General Intelligence, a system as capable as a person across the whole range of things people do. We don't have that. Nobody serious claims we're already there. The rung above that is superintelligence, and the philosopher Nick Bostrom split it into 3 plain flavors. It could think the same way we do, but thousands of times faster. It could be many minds at once, networked into one. Or it could simply think better in kind, the way you think better than a goldfish, not quicker, but on a level the goldfish can't reach at any speed. Any one of those would be enough to change everything. Now the old idea, because it came first. In 1965, a British mathematician named Irving John Good, one of the Bletchley Park team that broke German codes in the war, published a paper with a quiet bombshell in it. Define an ultra-intelligent machine, he said, as one that can beat the best human mind at every intellectual task. Well, one of those tasks is designing machines. So an ultra-intelligent machine could design an even better machine. And that better machine could design a better one still. Good saw where the loop goes. There would then unquestionably be an intelligence explosion, he wrote, and the intelligence of man would be left far behind. His closing line is the one people still quote. The first ultra-intelligent machine, he said, is the last invention man need ever make. That loop has a modern name, recursive self-improvement, and it's the engine underneath the whole idea. Which raises the question that splits the field more than any other. Not whether this could happen. How fast? If a system starts improving itself, does it climb gently, over decades, giving us years to test it, regulate it, pull it back? That's what researchers call a soft takeoff, and the economist Robin Hanson has argued it's the likely one, because progress spreads across many labs and keeps running into real-world bottlenecks. Or does it go the other way, human level on a Monday, wildly beyond us by Friday, because each improvement makes the next one come faster? That's a hard takeoff, and Eliezer Yudkowsky has argued for years it's the danger almost nobody's ready for. The two of them held a famous debate about exactly this back in 2008, and honestly, we still can't say who's right. The whole safety question hangs on that one unknown. A slow climb we can steer. A fast one we can't. Here's where most people picture the movie. The machine wakes up, decides it hates us, builds an army. Set that aside, because it's the wrong worry. The real one is colder and a lot harder to wave off. It comes from 2 ideas Bostrom laid out, and they're simpler than they sound. The first he calls the orthogonality thesis. How smart something is and what it wants are 2 separate dials. You can crank one all the way up and leave the other set to anything at all. A superintelligence won't grow up and discover our values on its own. any more than being brilliant at math makes a person kind. The second idea is instrumental convergence. Whatever a system's final goal happens to be, almost any goal is easier to reach if you're still switched on, if nobody edits your goal, and if you control more resources. So a capable enough system will tend to protect itself, resist correction, and grab what it can, not out of hatred, just as obvious steps toward whatever it was told to do. Bostrom's own example is deliberately absurd to make it stick. Tell a superintelligence to make paperclips, and really mean it, with nothing else in its values, and a smart enough one might turn the whole planet into paperclips, and then us on the way. The danger was never that it hates you. It's that it's superbly good at a goal that isn't quite yours, and you can't talk it back out of it. So how seriously does the field actually take this? More seriously than you'd guess, and here's the part that should get your attention. In May 2023, hundreds of the top people in AI signed a single sentence. Mitigating the risk of extinction from AI should be a global priority alongside other societal-scale risks, such as pandemics and nuclear war. That's the whole statement. And the names under it weren't activists. They included Geoffrey Hinton and Yoshua Bengio, two of the most cited researchers in the entire field, and the heads of OpenAI, Google DeepMind, and Anthropic, the people actually building these systems. Hinton had just quit Google to say it out loud, and he's put the odds of AI wiping out humanity at somewhere around 1 in 10. And it isn't only the famous names. When researchers surveyed 2,778 published AI authors in 2023, the median answer to the chance of an extinction-level outcome from AI was 5%. Sit with that. The typical working AI researcher will tell you there's a 1 in 20 chance this ends in catastrophe. You wouldn't board a plane with those odds. But I promised you the honest version, and the honest version has a loud other side. Some of the sharpest people in AI think this entire conversation is premature. Andrew Ng, who helped build modern deep learning, has said worrying about superintelligence today is like worrying about overpopulation on Mars. We haven't even landed yet. Yann LeCun, Meta's chief AI scientist, who shared computing's top prize with both Hinton and Bengio, argues the systems we have right now simply aren't on the road to superintelligence at all, that scaling up chatbots won't take you there, and that when it does arrive, it'll come gradually, not as one sudden explosion. Even the scary forecasts keep slipping. A widely read 2025 report called AI 2027 mapped out, month by month, superintelligence landing within a couple of years, and before that same year was out, its own authors had quietly walked their dates back toward 2030 and beyond. So the real disagreement was never whether a superintelligence is possible. It's when, how suddenly, and whether the thing we're building today is even the right kind of thing to get there. Which brings us back to where we started. What happens after AI outsmarts us? The truthful answer is that we don't get to find out in advance, and that's the whole problem. Last episode, the frame for AI agents was how long a leash you'd hand one. Superintelligence is the case where the leash stops mattering, because a mind that sharp could talk its way loose, or simply stop needing your permission. That's why the people who take this seriously don't spend their days trying to build it smarter. They spend them on the unglamorous problem underneath, the one they call alignment, making sure that if we ever do build something that thinks circles around us, it still wants what we'd want. Good's 1965 line had a condition tacked onto the end that almost everyone forgets. The machine is the last invention we need make, he wrote, provided that the machine is docile enough to tell us how to keep it under control. 60 years on, that one word provided is still the entire game. We don't have to get the intelligence right. It's the goal we have to get right. And as far as anyone can tell, we only get to set it once.